Okay, so you're gonna do the 5 number summary. There's a couple different ways you can do this. You can either put it all in Desmos. Um, the only thing that this Desmos will do for you on this one is find the min, the max, and the median. And that's kind of easy if you just go ahead and list them out. So we're gonna list them out from least to greatest. What? All right, excuse me.
All you do is put stats and then put X and then you want to keep it.
Okay, so let's try it. If this will pop up. Okay, so when you put this in, you're gonna say X and make sure that you use like a capital letter for whatever list you're making, because otherwise it defines it as a variable instead. All right, are there 12 things? 3, 9, 12. Okay. And then now we're gonna do min of X. We're gonna do max of X. Median of X. And you're saying that it does Q1?
Yeah.
So you have to put, boom, there it is. Okay, you got to know how to do this. Like, I can't do it for you, or I'm not going to tell you. Okay, and there's your Q1, Q3, median, max. Thank you. Okay, we good? Stat X. Make sure that you put bars around your element, and then make sure that you use a capital letter for your variable. Okay, shouldn't get those questions wrong. Interquartile range is Q3 minus Q1. So Q3 is 300. Q1 is 125. So what's 300 minus 125? How much? 175. Okay. Any outliers? So the way you do outliers is you do Q1 minus 1.5 times IQR and Q3 plus 1.5 times IQR. So Q3 was, or Q1 was 125 minus 1.5 times 175. And Q3 is 300 plus 1.5 times 175. You're going to take those, plug it into your calculator. Your bounds are negative 137.5 of 562.5. Are there any numbers in our list that are outside of those bounds? Is there any number that's lower than negative 137 or higher than 562? No, so there's no outliers. Did I do this number wrong? I don't think so. Okay. All right, on the next one. Use the data to give the 5 number summary. Make sure that you create your box plot. Remember, the box plot is our min is 12. So we're gonna put a dot here. Q1 is 34. Line here. Median is 40. Line here. 48. Line here. 64. Dot here. Connect your stuff. Ta-da! Box and whisker. Okay, or box plot. Interquartile range, that's Q3 minus Q1. So that's 48 minus 34. That's 14. Are there any outliers? Yes. Okay, and that's going to be 12. Again, the way you do it is Q3 plus 1.5 times IQR and Q1 minus 1.5 times IQR. Questions on that one? Yeah, you're right. I didn't do this key. Yeah, sorry. Good try though. I'll let the other teacher know that Osiris pointed this out. Good? Yep. Did you get a different number for the rain or the
60.
okay, so let's try it. Again, didn't do this key. So what's your Q3?
40
Plus 1.5 times what's your IQR?
14.
Okay. Yeah, 69 for the top one. And then what's your Q1? Minus 1.5 times IQR, which is 14. So I got 13 to 69. Sketch the graph that meets each of the following characteristics. Here you go. Remember, bimodal is 2. Unimodal skewed right is 1 hump with the right tail. Okay. Skewed left has a left tail. Uniform is straight across. Okay. Good. The normal distribution question is probably the most frequently missed question just because, like, I don't know, people rush through it. Okay, so look at number 4. And it should be easy. Should be. Keyword. Okay, so you're given an IQ score that's normally distributed with a mean of 100 and a standard deviation of 15. So when you get your normal curve, you're immediately going to put in the middle 100, and then the standard deviation is 15. So you're going to add 15 to the right-hand side and subtract 15 on the left-hand side. So you see how we went 100, 115, 130, 145, and then we subtracted 15 this way. Okay, so then it says what percent of people have an IQ between, 68% have an IQ between 85 and 115. Okay, 68 is in that middle piece. This is the empirical rule. 68, 95, 99.7. Yeah. Those are 3 numbers I would probably have memorized. Okay. And then from 70 to 130 is 95%. What percent of people have an IQ above 85? So we're going to go to 85, and then we're going to add up all these percentages. That's how we get 84%. Are there any questions on this one? Like, don't get this one wrong, respectfully. Okay. What percent of people have an IQ between 70 and 100? Again, you're going to just kind of like mark it off 70 to 100, and then you just add the percentages in the middle. Shouldn't be hard. Yeah. Okay, I need you to do this. Okay, go ahead and put this data in a table on Desmos. Okay, so take a, all right, so using Desmos, write an equation for a linear regression model in the form y equals mx plus b and calculate the r-squared rounded to decimal places. So, couple different ways you can do this. If you have a certain Desmos, what you can do is just hit add regression line, and it should pop up. Why are you not popping? There we go. All right. And there's my equation right there. Remember, rounded 2 decimal places, don't write out the 7. Okay, so this would be 0.77x plus 0.31. Okay, here's my r squared, which is 0.97. let's say this is not an option on the Desmos because there's some Desmos features that are different for each graph calculator. Okay. If for some reason you don't have this little button on the side, what you can do is you can write y sub 1 little tilde mx 1 plus b.
How do you do it?
You hit shift and then in the top left-hand corner, there's a button. It's like an accent mark. So look at your keyboard and it should be shift and then the top left, it's above like tab or cap lock. Yeah. Okay. This is the one that you need to know. I'll write this on the board. Okay. So if for whatever reason the Desmos doesn't work or whatever, you don't have like the add regression button, you can also do this. Okay. And then all you do is you say 0.77 plus x plus 0.31. It's the exact same thing. When you want to write the equation, when you want to write this equation, your r squared is also given. Good? All right. Use the model above to estimate the mass of plant on day 13. So all you're going to do is take 13 and plug it into this equation. Okay. If the trend continues above, on which day will the mass plant equals 25 grams? So this is going to be your y. So you're going to say 25 equals 0.77x plus 0.31. You're going to go into Desmos, type it in, see where it crosses the x-axis, and it solves it for you. 25 plus equals 0.77 plus 0.31. And when you zoom out, it crosses at 32.06. Or day 32. Okay. This is the tricky question. What does the slope mean in context? You have to reread the word problem and then put it in context. So what are we talking about? We're talking about as days continue on, how big something is growing. We're talking about small plants. So the mass of the plant increases by an average of our number 0.77 grams per day. Okay. We good? Okay. Quick. Coming back up to, like, let's say this one. Okay. If you were given something like calculate the percentage between 90 to 105. Okay. You're going to have to use the z-score formula. So remember, that's this one. Yeah. Okay. So deep breath. Take your point, 90. Subtract your mean, 100. Divided by your standard deviation, which is 15. Tell me what you get. Okay, so negative 0.67. We're going to go into our table and look for negative 0.67 in our table. And then we're going to pull the number that's associated with that, right? Okay, so if I go into my table, do we need to show you how to use a table? Okay. All right, so we found the negative. So we're going to go down here at negative 0.6. We're going to go over to 0.07. And that's going to give me this number right here, 0.2514. Okay. Now, we're going to do the exact same thing for 105, though. So we're going to say 105 minus 100 divided by 15. And that gives me 0.3. Okay. Is it 0.33? Yeah, okay. So I'm going to go back into my positive table. 0.33, go over to 03. And it's 0.6293. 0.6293. Okay, yes, I'll give you this table. They gave it to us in our problem. Let's say that they said calculate the percent between these two numbers. Those are your x's. Yeah. Okay. So now you're going to take these two numbers and you're going to subtract them. 0.6293 minus 0.2514. Tell me what you get when you subtract those two. So it's 37.79% that fall between 90 to 105. Yeah, that one's a little tricky. That's the worst of it. Okay. Yep, just to say a percent. Yep. So this is mean. This is standard deviation. And then this is whatever X values they give you. So like the 90 to 105, 90 is your X. So it's kind of like point minus your mean divided by standard deviation. Does that answer it? Okay. Good. Questions? Okay, yes, you're going to get your table. Yes, you're going to get Desmos. Yes, I'm going to give you the formula. Cool. Are you ready? All right, let's knock it out. Go ahead and clear off your desk except for your laptop. You're going to go